Microsoft MakeCode is a web-based platform for hands-on learning that provides a simple introduction to programming for those with little or no experience. Even beginners can use their imagination to create projects with motion, lights, and sound. It allows you to create instructions for physical computing devices in a graphical drag-and-drop block editor. In this tutorial, MakeCode combined with an Adafruit Circuit Playground Express can be used to make sounds, light LEDs, or power motors, all while interacting with its environment using the many onboard sensors such as audio level, light level, motion sensing, and input buttons. Circuit Playground has built-in USB support. Built-in USB means you plug it in to program it. It just shows up. All you need is a micro B USB cable. To get started, plug the Circuit Playground into the computer using a USB cable. It will pop up as a removable drive called C-Play Boot. To program the Circuit Playground, we use these categories and the objects within them. To place objects on the program board, we select a category. Within that category, we select this object. To place a subcategory item in, we select its category and the object within that. To plug that in, we hover over the object until it lights up gray. Then we know we're able to plug in that item directly. In the object, we can change its parameters by clicking on the drop-down menus. There are three methods to deleting an object from the program board. The first is simply clicking on the object and dragging it to the category panel. You'll see the trash icon and just let go. The second way is to right-click on the icon and use the delete block menu item. The third way is to highlight an item and just simply hit the delete button. Let's create our first program and test it in the Microsoft MakeCode Circuit Playground Simulator. To start, let's create a magic wand. To start the magic wand, let's use the shake function. The first thing we'll do is go ahead and light the magic wand, and we'll show an animation to do that. We'll show the sparkling animation, and we'll let that play for 2 seconds. We'll follow that with some sound. So we'll play a sound, and we'll choose magic wand. Finally, we'll interact with our world using infrared. Infrared can be used to program devices, and this can send that IR code directly to it, thereby making the animation and the magic wand do something all at the same time. We can see that this is active in our simulator. When we shake it, the animation lights and the sound plays. To show Microsoft MakeCode's interaction with the physical Circuit Playground, I created a short program that shows an animation or plays a sound depending on the value of the light sensor. To download this program to the Circuit Playground, we click the download button. Use the USB cable to connect your Circuit Playground to the computer. Press the reset button, then we'll go into programming mode. When the lights turn green, you're ready. Copy the Circuit Playground program to the C-Play Boot device that shows up when the Circuit Playground is plugged in. Once it's done transferring your file, the board will automatically reset and start running your code, just like in the simulator. For this example, we use the light sensor. When the light goes dark, the animation plays. When the light gets bright again, a sound animation goes. This is useful when you want to have a box and you want to place the Circuit Playground in there to make use of the sensor. Once the box is opened, the sound plays, or any other sort of thing that you program the device to do. The benefit of using this tool in an educational setting is that it's a low barrier to entry. Learners don't need to know complicated programming languages in order to make fun projects. They are learning the concepts of how to execute behaviors based on logic and inputs. Beginners in this area can be creative and innovative by making prototypes with a simple interface. The physical model, which is the Circuit Playground Express, helps designers create mental models that are accurate. According to Forrest et al., physical models help designers visualize and estimate attributes. They validate assumptions and verify functionality of their ideas. According to research done by Su Ching and Baldwin 2018, educators felt that their projects were improved due to the peer feedback that they received from their colleagues. They also considered the collaborative experience to help them achieve common learning goals and fulfillment. The drawbacks to using this tool are 1. Cost. Each student needs to be provided a $30 Circuit Playground kit and materials to build with. 2. This pedagogy is by nature time-consuming. Students are following their own path to answer the driving questions. 3. Assessments may become more complex. Learning has to be discovered in new ways. And 4. Learners who are inexperienced with problem-based learning may require simpler forms of this type of learning to develop the skills they need to succeed. According to Prensky and Heppel 2010, the students are challenged to solve a problem or meet a need with their inventions. They will work individually and are encouraged to follow their passions when designing a project. The learners choose their own path to answering guiding questions, and the teacher serves as a facilitator or learning partner. Teachers give learners experience with digital tools, as well as guide them to finding other tools to supplement or potentially replace what they are using to continue or advance. Students can use this skill to support lifelong learning. Collaboration and sharing of experiences leads to lessons that go beyond many of the common learning goals. It is challenging to balance the breadth and depth of learning, but the reward is students who think logically, take prudent risk, think creatively, make decisions, experiment, observe, problem solve, design, make, and innovate.